Okay, this is lesson 6.3, or I'm sorry, lesson 6.2, video number 3, and this is still properties of rational exponents. But one thing that we're actually going to be working on in this video is actually simplifying radicals. If you recall, when we started working with radicals, whenever we found the third root of 125, whenever we put that in the calculator, we actually ended up with 5. However, when we found the fourth root of 5, we found out that that actually ended up, it was about 1.49. So it didn't come out perfect, and it's actually called remember, it's called an irrational number all the way from Unit 1. And so we really don't want to deal with any irrational numbers. All of the numbers that we want to deal with, we want them to come out nice and pretty and perfect. So sometimes we just have to leave them in radical form. So the very first thing to make this a little easier for you is you should have printed this paper off. And so what I want you to do is I want you to pause the video at this time. And I want you to, when you pause the video, I want you to make sure that you've actually completed this. So what we're actually going to do is we'll go ahead and fill the first column out, and we'll start the next column so you get an idea of what you're actually supposed to do. So I'm looking for, if this is this column is the value of x. So x is 2. Now I'm looking for what's 2 squared, and 2 squared is 4. Now, the next one would be 3 squared. 3 squared is 9. And I want you to finish this out. 4 squared would be 16. 5 squared is 25. 6 squared is 36, and so on. So, and as you're going across the column, now I'm looking for what is 2 to the third. So 2 times 2 times 2 would give us 8. Next one would be 2 times 2 times 2 times 2, so 2 to the fourth, which would give us 16. And the last one would be 2 to the fifth, which is 32. You're going to find that this paper is going to be a tremendous help. So go ahead and pause the video at this time if you have not already finished this page out, and go ahead and finish this page. Okay, at this time, go ahead, and these are actually what all of the answers should be. So make sure that you pause the video now with all of these answers, and make sure that you actually have all of them correct, and that everything is filled out appropriately and you found all of the numbers, because these are going to be really, really important in order to proceed with the lesson. So, all right. So example number 1 is we're looking for the cube root of 54. So let's go ahead and click on the calculator, and we're going to look for the cube root of 54. So let's find this really quick, because sometimes these things will actually come out to be a perfect. So I'm looking for 54, and oops, let's clear that out. We want 54, and we want the cubed root. So notice how I have the cube root of 54. It's going to give me 3.7797, and it actually keeps on going. This is all the computer would actually show. So what we're actually going to do is we're going to go back to that slide. Now I'm not going to go back to these slides every time. You'll have to refer back to it, but I want to know, this tells us which column we're going to look under. So this will be actually going under the cube root. So let's go ahead and go back, and I want to know. So in other words, we're going to look under this column right here, because this is all of the cube roots. Okay. Now a clue to this is, if I actually take this, let's pull up this calculator real quick. If I actually take the cube root of 54, actually I want to take 54, and I want to divide it by one of these numbers. Well, there's no sense in dividing all these. I want to start with actually the smallest number. So I find that it's actually 27. So 54, to see if it'll go to 54 divided by 27. And I actually get 2. So 54 divided by 27 is 2. So I know that I can actually take the cube root of 54, and I can break this up into the cube root of 27 times the cube root of 2. Now, if you remember the cube root of 27, the cube root of 27 is actually going to be this number right here. Okay? So 3 times 3 times 3 will actually give me 27. So, in this case, the cube root of 27 is 3. This one I cannot simplify. There is no cube root of 2, so I'm just going to bring it down, and it's going to be the cube root of 27. Okay? And that's your final answer. Okay? All right, so let's take another look at another example. Okay? So now I'm looking for the cube root of 975. So if you look at that list, let's go ahead and pull up this calculator. If we go all the way down the bottom of the list, the 10 to the third power would actually give us 1,000. Okay? So you can try taking 1,000 and dividing it by, I'm sorry, let's try this again. 9,375 divided by 1,000 and see if it goes. Well, it doesn't go evenly. So let's go up to 729. 9,375 divided by 729 doesn't go evenly. And I'm just going to keep working my way up until I find something in that third column that will go into 9,375. So let's keep going to 512. Doesn't work. 9,375 divided by 343 doesn't go evenly. 9,375 divided by the next number is 216 doesn't go evenly. 9,375 divided by 125, I find out that 9,375, I can now split it up into, because it was 125, so I go the cube root of 125 times the cube root of 75. Okay? Now you can see if you can break it down any further, but 64, 27, and 8, none of those are, 75 is not divisible by any of those. So the cube root of 125, if you look at the 125, look over, you're going to find out that it's 5. Forgot the cube root on there. Cube root of 175, cube root of 75 rather, is just 75. So this is actually my final answer. Okay? All right. Now, whenever I'm including radicals, I'm sorry, let's go ahead and pause the video at this time and see if you can find what the cube root of 576 is, and we'll have the answer available when you're done. Okay, so if you go up the list, and remember you only have to start with the numbers that are actually smaller than 576, so you could have started with 512, 343, 216, 125, but the first one that you actually come to, 576 divided by 64 actually gives you 9. Or you can take 64 times 9 will give you 576. And the cube root of 64 is 4. And then it's, since there's no cube root of 9, we're gonna leave it the cube root of 9. Okay, as our final answer. Okay. All right. Now, whenever you're doing these, if you're going down the list, you quickly see that there is no 16th root of 8, or we actually can't simplify these. And the reason that we can't simplify these is because, remember, whenever we simplify these, we have to have the same number inside the radical as well as the same index. So this one can't be simplified. 2 is as simple as it can get, but this one can be simplified. And if you look at that list, you're going to find out that this is going to be the cube root of 8 times the cube root of 2. And the cube root of 8 is 2, so we're going to bust this one up into 2. Cube root of 2 minus cube root of 2. So now that I have the same index, the same number under the radical, now I can subtract those. So 2, remember this would be an invisible 1, so my final answer would just be the cube root of 2. Okay? All right. So now when I'm actually doing these with variables, the 27, since it's the coefficient of the z, actually is going to stay exactly the same. That is not going to change. We're going to do that just like we've been doing. So if you work up the list for the cube root, you're going to find out that, hey, wait a minute, 27 is a perfect cube. So the cube root of 27 is actually 3. When it comes to the z's, all you're going to do is you're going to take this power and divide it by 3. So 3 divided by 3 gives me 1. So it's 3z is your final answer. Next one. All right, so if I'm looking at this, now if you'll notice on all of the examples that we've done, our index has been 3. Now all of a sudden our index is changing to 4. So that indicates all this 4 is going to tell you is that we need to look under the 4th column, the x to the 4th column. And if you're looking down that list, you find out that, wait a minute, 32 is not under that column. So we're going to work our way up. So all of the numbers are larger except the 16. And so I can actually split up 32 into the 4th root of 16 times the 4th root of 2. Okay? And then we're going to leave it the 4th root of d to the 5th. Okay? So the 4th root of 16 is 2. This is not perfect, but I need to find out what I can pull out. So all we're going to do, the best way to do this is take 5 divided by 4. We'll go 1 time, and I have a remainder of 1, just like we did in elementary school. This number, however many times 4 will go into 5, indicates how many we're going to pull out. So in this case, we're going to pull out just 1d, and then it is the 4th root, anything that's left over. So like this is left over, and this remainder is left over. So anything that's remaining left over actually stays under the radical sign. Okay, so to be 2d, 2d, and then the 4th root of 2d. Okay, all right. So let's take a look at another example real quick. So notice we're back to the cube root. So the cube root of 8 is actually perfect, and that comes out 2. Okay, 3 will go into 3 1 time, so we're going to pull 1 factor of r out, and we have none left. So we're going to scratch it out. 3 will go into 5 1 time, so we can pull 1 factor of s out, and we actually have 5 divided by 3 is 2, and we have 1, and we have a remainder of 2. This got left taken out. 3 will go in, or 10 divided by 3 will go 3 times, and we actually have 1 left over. So all of the remainders that are left actually stay under. So the s squared and the t all stay under. So that's what our final answer would look like. Okay. All right. Last example would be this one. Okay. Now we're still looking under the 3rd column. Okay. Now remember, this number can change depending on if we're looking for the 5th root, the 4th root, the 3rd root, or even the squared root. Remember, if it's squared, it's not going to be under that list. So we need to find what number can we divide by 108. Okay. So let's go ahead and pull up our calculator. And I want to know 108 divided by, well, let's actually start with 64, since that's the smallest number possible. Get a decimal, doesn't go evenly. So 108 divided by 27, we find out that it's 4. So this can be split up into the cube root of 27 times cube root of 4. Okay? All right. And then all of our letters. So the cube root of 27 is 3. All right, so the cube root of 27 is 3. This is not perfect, so it's going to stay under the radical sign. So we've used this up. 4 divided by 3 is 1, so I pull out that 1a, and I have a remainder of 1. 3 will go into 6 twice, so I end up pulling out 2 factors, and then I have none left, no remainder. And then 3 will go into 11 3 times. It's a C. Three times, and I'm actually going to have a remainder of 2. So anything, once I pull out all of those perfects, remember, everything that's under the radical just stays there. So I'm left with 4ac squared. Okay? All right. If there's any other resources that's needed, a great resource that you can actually do is go to YouTube and type in simplifying radical expressions. And I'm sure there'll be extra videos that'll pop up should you need any extra assistance.